Hello, welcome to my channel. Now, I've drawn this graph so that we can follow the game a bit better and keep track of what we're doing. Now, on the board, the user's only got 3 actions. You can either press one of them keys, you can press the force move or press the reset. I'm going to be concentrating more on the force move and probably the reset for now. And I'll tackle the human making a move afterwards. So for the reset key, basically you want to run a reset method and run a start game method. For the force computer move, what you want to do is you want to make a computer move, flip sides, and pass the human to make the move. Okay, so when I say pass human to make a move, it's the actual state what it's in now. It's waiting for someone to make a move. So the human can either press the force move, then the computer will move forward first, or you can do a reset. I mean, you can set the board to whatever size you want and do a reset, and make a move yourself by clicking on one of these. Okay, so first I'm going to just concentrate on the force move, because what we can do is, if we keep pressing force move, you can make the computer play a game against itself. So that's what I really want to do. I want the computer to play against itself so I can do a bit of tests on it to see if it's working. So I'm not going to bother with things like if it's following a line or if. I just want it to play some moves against itself. So that's what I'll be concentrating on in this video. Now, I'm going to change a few things in the program that I noticed, and it's one of them is this. I'm going to change that to double X. The reason I'm going to change it is sometimes libraries use these funny symbols, these obscure symbols to mean something, and when you put them in, it causes bugs. So I'm going to take it out there, and all that means is, I can't remember where it is, but I'm going to have to change. That's called a config, so I should look for something called config. Yep. So if I just put double X there, then it does exactly the same thing. Okay, so at the moment, when we press reset, it should be console login. Let me have a look. So it's this control. It's a control. So let's see what happens. It does this start game. So it just does a reset. Okay. Now I'll show you something. On the other video, I showed you that when you do reset, it does that. And if I set it to a 3, it does that. Now, if I do the same thing with the force move, that also does it as well. The reason why is both of these are that come from the same component, which is this one here. So they both call this. So whichever key, whichever one of them two you press, it calls. It calls start game. Now we can separate them out. And I'll show you how. Right. My internet might be down. Okay, so what it is, I kind of want I'll do a refresh. Okay, when I press force move, it fires a different event. Can you see? We can tell. One of them does a one of them fires a different event. So what we can do in this is, let me press both of them. Okay, handle control. If equals reset, we do something, and then we're going to do an else, and we're going to be accurate here. We're going to do else if. And if equals false, we're going to do something else. Okay, so when we set, we will do we'll do this. And if it's false, we're going to run a method called force move. Which I haven't created yet. So the first thing I'm going to do is create this method. I'll just create it under here. First thing I'm going to do is test that it's working. Let's just do that. And that's a made mistake. Okay. So let's click that forced. So that's how we can do things. Even though these have got the same event, we can do a separate method for each one by doing that. Okay. So forced is we're just going to force the computer to make the board and move on this position. Before we can do that, we have to add a method to this. We don't have to. We could modify this, but if we modify this, I may want to test something. So I'm not gonna modify this. What I'll just do is I could basically create a copy of it. So I've got one that I've done earlier, and I'm going to just paste it in to save a bit of time and talk about it. So what this does, if I open the other one up, get computer move, it does nearly the same thing. However, let me just open both of them up. Get human move, it's not that one, it's get computer move. Right. In fact, I've done something wrong. Let me do that. In fact, I'm going to paste it here next to it so that we can compare them easier. Okay, if we look at these two, you're going to see that they're exactly the same. Line for line. Okay. However, this one hasn't got a console log in it. And this one actually, after it gets the best move, it actually makes it on the board. So what this one does, this one just gets the best move and then it returns the best move. For instance, it might say the best move is 53. So it's just going to return 53. Whereas this one, when it gets to here and it says get the best move might come up as 53. So what it will then do is, it will actually make the move on the board. The reason why it will make the move is because it needs to return the result to the position, which is here. So this will tell whether somebody's won. It will tell who's won or whether the position's a draw. And to be honest, I might make it return a bit more because we need to know when when the game is finished, as in, can any more moves be made? And then we're going to know the game is a draw. So at the moment, I'm going to leave it like this, but we may need to add a bit more in it. Okay. So this one, it prints the things in the console. This one returns it all as an object. So that's the only, as you can see, that's the only difference. And this one returns the evaluation. It actually makes the move and returns the evaluation. This one, it returns the move but doesn't make it, and it returns the evaluation. But this one actually makes the move. The reason why it has to make the move is, I need it to make the move and I need the evaluation. Okay. So once that get computer move is there into that class, then I can go back to here and I can use it. Now what I need is, let me just check the unions. In fact, I've made a mistake somewhere, but what I'm going to do is, I'm going to put the extra stuff in. I'm going to put the depth. I'm going to set it to 6. Alright. And I also need the side to move. I'm going to set it to 0. What do I need? I need, just like the other one, I need the values for yellow, red is 0. If I don't need them, I'm just going to put them. Well, I may need them. And yellow is 0. And one thing, you know, this line here, these other ones, I can see the effect of them when what it is. The line, I forgot all about that. So I'm going to add the line in there. I'm going to default it to 4. I'm going to have to put the line, I'm going to have to put the line in properly. So what I'm going to do is find out where, I think I know where. I'm going to have to string the line up properly. So before I do anything else, I'm going to get the line done properly. Just got to work out where it is. If I go to the start method, I think that'll be a good place to start. Yeah. So what I've got to do is, the line is in there, but I forgot to put it in for some reason. So all I've got to do is, so just like the width and the height, it's going to be the same thing for the line, but I didn't notice it before because it's not, it hasn't got an effect, whereas the others have got an effect. So I'm going to take this line out. Okay, so that's, I've put the line back in, and I've put some extra properties in here. Okay, so with that done, now I'm going to go to the force move. And all it's got to do is make the force the computer to make a move from the current pole position. Okay. So how am I gonna do it? That method that I just created. I'm going to use that method. All right, so I'm gonna put. So that should return an object to me. Okay. Now the size and the depth, I need to get it from here. Remember what I said? I can't get it from here. I can't get it from here. I can't get the height, the line, or the depth from here. Otherwise, when I change it like this, it will change on the board. I want to be able to change it, then press reset, and then that's the only time it will take effect. Okay. So I need to get these values from here. So what I'm going to do is I'm going to use my favorite new feature for JavaScript, and that is a destructor. Okay, so I'm going to do let. And what do we need? Side equal this dot. Okay, so what we've done is on force move, we get the values from enum. Let move equals this, get computer move, side, depth, but I just remembered that. This returns an object, so let me just do that. And then what I have to do is I have to flip the side. And that's the standard thing that we do, bitwise operation to flip the side. And then after it does that, what can it do? In fact, what I'll do is I will console log. I'll just console log this. So I won't flip the side. In fact, I will flip the side, but I'll console log that. So what I'm going to do, I'm going to set it to a small board first. I just want to make sure that it's doing the right thing. So I press reset. And if I do force move, I should get an object come back. I didn't, so I missed something. I think I spotted my mistake. This should be enum dot AI dot get computer move. Okay, let's see what happens now. So what we have to do, we have to just set it to a smaller board. I'll set it to a 4x3. I'll set it to 3 in a line, and I'll reset it. And then I'll do force move. And as you can see, it is working. So it's made a move, and it's looked at, it's went to a depth of 6. 4393, if I do it again. So it's actually making the moves. So before I go any further in this, what we need to do is, we're not seeing it on the board because we haven't told it to render. There's nothing to tell it to render. So when I done this first, I made a bit of, not a mistake, but I need that to make it easy for myself. I need to split this up. You know the reset key? I need to run a reset method, then start game. And all that simply means is, in here, I won't run start game, I'll do reset. And I'll create a new method called reset. So this one, everything in here that does a reset, I'm going to put it in the other one. So it's all of this resets it, as you can see. Okay. So I just need to put that in there. So now that I've taken that reset out, that reset stuff, start game, all it does is it just starts the game. So what I can do is, so start game, this set state that will cause a render. It will get the board, then we'll do a render. So what I could do is, here, after it does the move, it's got the move object, and at this stage, if I do start game, then that will re-render. Now I've got to change the reset. I've got to change the reset one because wait, the init that does a reset. So I've got to change something because something else was calling the reset. That needs to call reset. And I forgot that in reset, after it resets, you have to start the game so that it needs to render. So what it is, all I have to do is and that should be it. Once it comes on, I should be able to play. Right, what's the depth? The depth is set to 6. So I'm going to set it to 8. I want to test something. So I'm going to get it to play a game now. I'm going to look at the move object to see what's going on. Wait there. Yeah. Just checking something. Okay, so we're going to set it to a smaller board, a 5x3. And we're going to set it to play 3 in a line. It's not going to play 4 in a line, it'll play 3 in a line. So press reset. And now it's going to look for 3 in a line. So what I'm going to do is force move. And as you can see, it's got the evaluation is 0, best move is 4, best move score is 4. Now if I force move again, now it's playing for yellow, and it's got best move is that, and the score is 4. It's done it again. It's done. I just want to check that it's playing properly. Now I think normally it would go here, but obviously you can see a win there, so it's not going there. But anyway, okay. So now red has seen that he can't win, because can you see that score with -96? Can you see? So we're just going to go through the moves. So red can't win now. So can you see this evaluation 100? So therefore, that way you can tell who's won. However, I can still make more moves on the board because I haven't put any logic in it to stop when I win. Like when there's a win, it's supposed to stop, or if there's a draw, it's supposed to stop. But there's no logic for that. So I'm just doing this as a test. So let me just check something. I want to put a depth of. I'm going to put the depth at the bottom because the depth is probably something I'm going to change quite a lot. So I just put it here, just so that I can reach it easier. Okay, so we're going to set a small board, 5x3. And the depth is, let's set it to 9. And let's do another check. Five by 3, and we set it to 3 in a line, not 4 in a line. So I know that somebody must win this game because it's only 3 in a line, and it's easy. You know, somebody's gonna get 3 in a line. So I force it. And it hasn't found the win yet, because as you can see, in fact, it's already found the win, 95. So what it's done is, as you know by the programming, it starts here and it looks for the best move and it will give it a score. And if it doesn't find a better score, then it would make the move here on the first column. Fahowever, in this case, it went here, found the best score, went here, and it found that a better score is here. So so the mere fact that it played there, it's already got, as you can see, because it's looking to a depth of 9, it's already found a win. So this game, in a 5x3 board, it's a forced win for one team, no matter what you do. So we're just going to go through the game. So can you see the win now? Yellow cannot go here. Yellow can't go here, because if yellow goes here, red is going to win here. However, if red goes here, he's got 2 ways to win. Can you see? One here and one there. So at this point, yellow can't win. Can you see? 2 ways. One here, and if you put that there, if you block that, he's going to go there. Now look at the evaluation. That's the important thing, is that evaluation. So that will tell us. So we don't have to do any calculations in here to find out who's won. It's just there. So all this class here, of every new class, every new thing that I add in here, I'm going to put an underline to it. Okay. So this is a slight modification of that one, in that it actually finds the best move, and then it actually makes the move on the board, and then it returns all this information to us in this object. Okay. And then when it's being displayed, to cut a long story short, what our system does is it gets the board that is on here. It just gets the array, and it just puts the array, puts the objects there, and all it's doing is showing us what's there. It's not thinking. This one is doing all the thinking. The thing that we built before, and this is just, the view. Okay, I'll end the video there, and the next one I'll continue. This force moves isn't finished yet, because we've got to account for winning. We've got to account for what if one person makes a move and wins. What if the position's a draw? So if it's the computer's move, the computer's going to either make a move and win, or it's going to make a move and draw. So we need to handle them two situations. Okay, thanks for watching the video. Until next time, bye.